guys, it's Miss Adams, and we're going to be looking at the Unit 7 test review. So remember, this whole unit was all about graphing quadratic functions. This first page goes on to look at graphing these quadratic functions and just different versions of these quadratic functions. So let's look here, just looking through this, it's got our quadratic functions given in three different forms, either standard form, factored form, or vertex form. So looking at the first two, there's no parentheses in them, so I know already that these are in standard form. And our standard form gives us the y-intercept. So just by looking at these, I can tell that the y-intercept for number 1 is at 0, negative 12. And I can tell that the y-intercept for number 2, well, it's just 0, so my y-intercept is going to be at 0, 0. Now, if you look at the table that I gave you for number 1, it actually doesn't contain the point 0, negative 12 because that goes off of our coordinate plane here. But that's okay. Into the table function we go in our calculator, and I'm going to enter in that negative 1/2 x squared minus 4x minus 12. And I'm starting at the value where x is negative 6. So when x is negative 6, I get a y value of negative 6. When x is negative 5, I get a y value of negative 9/2. But guys, I kind of struggle with graphing fractions, so I'm going to go ahead and convert that to a decimal. So that's going to give me negative 4.5. When x is negative 4, y is negative 4. When x is negative 3, y is negative 9/2 again, which is at negative 4.5. And when x is negative 2, y is negative 6. So if I'm graphing this where x is negative 6, y is negative 6, where x is negative 5, y is negative 4.5, so it's going to be right there in between negative 4 and negative 5. When x is negative 4, y is negative 4. When x is negative 3, y is at negative 4.5 again. And when x is negative 2, y is at negative 6. And we have our downward facing parabola. For number 2, I had y equals negative x squared minus 2x. So I'm going to enter that function into my calculator. I've got negative x squared. So make sure we're hitting the negative button and not the minus button there. Then we can do minus 2x. And now we're starting at negative 3. So from my calculator, when x is negative 3, y is negative 3. When x is negative 2, y is 0. When x is negative 1, y is 1. When x is 0, y is 0. And when x is 1, y is negative 3. So I've got negative 3, negative 3, negative 2, 0, negative 1, 1, 0, 0, and 1, negative 3. And we can actually see our y-intercept there at our origin 0, 0. And this is also a downward facing parabola. Let's go to problems 3 and 4. These are in vertex form. We can tell that because it only has one set of parentheses for both of these. So these are both in vertex form. And our vertex are that h and k value. But remember, h is inside of the parentheses, so I've got to switch the sign. So my vertex for number 3 is going to be negative 1, negative 3. And my vertex for number 4 is going to be at negative 4, 3. Now notice, we didn't give you the values of the table. And this is because we wanted to show you that when given in vertex form, make the vertex the center of your table. So I'm going to put the point negative 1, negative 3 in the center of table 3. And in the center of table 4, I'm going to put negative 4, 3. And from there, I can use the table function of my calculator. And I'm going to enter in negative, open parentheses, x plus 1 squared minus 3. Now, I want that negative 1 to be my center, and it should be my turnaround point. So let's look at some other points around it. I can go negative 2, negative 3. And I can go negative 1, 0, and 1. So when x is negative 3, y is negative 7. When x is negative 2, y is negative 4. When x is 0, y is negative 4. And when x is 1, y is negative 7. And in the calculator as well, my x value of negative 1 gives me a y value of negative 3. When I graph this, I've got negative 3, negative 7, negative 2, negative 4. My turnaround point at negative 1, negative 3, 0, negative 4, and 1, negative 7. So this again is a downward facing parabola, and it is symmetric. Now let's move on to problem 4. I know that my vertex is at -4, 3. So I could keep going a little bit more negative, go -5, -6 for my x values, or come a little bit more positive, so -3 and -2 for those x values. For my function, I'm going to enter in negative, open parentheses, x plus 4, close parentheses squared, plus 3. So I'm starting at -6. So when x is -6, my y value is -1. When x is -5, my y value is 2. When x is -4, my y value is 3. When x is -3, my y value is 2. And when x is -2, my y value is -1. So I've got -6, -1, -5, 2, -4, 3, which is my turning point, -3, 2, and -2, -1. Which leads us to our functions in standard form, or excuse me, not standard form, but factored form. Notice these have 2 sets of parentheses, so I know that those are in factored form. And I should have 2 x-intercepts for both of these. When I take anything out of parentheses, I've got to change the sign. So my first x-intercept for number 5 should be at -4, 0, and my second one should be at -2, 0. Then I'm going, sorry about that phone call, guys. For number 6, I'm also going to look at the x-intercepts there. I'm going to have one x-intercept at 1, 0, and the other one should be at -3, 0. So looking at those tables, I can already put my x-intercepts down for -4 and -2 for number 5, and for number 6, when x is 1, y is 0, and when x is -3, y is 0. So let's go back to the table function in our calculators and plug in open parentheses x plus 4, close parentheses, open parentheses x plus 2, close parentheses. We're starting there at -5. So when x is -5, y is 3. It tells me that when x is -4, y is 0. When x is -3, y is -1. When x is -2, y is 0. And when x is -1, y is 3. So I've got -5, 3. But notice that goes off of our coordinate plane a little bit, and that's okay. We can start at -4, 0 here, -3, -1, -2, 0, and -1, positive 3, which is also going to go off the coordinate plane just a little bit. As long as you have 3 points, you should be able to graph these functions. And let's go to problem 6. So I'm going to go back into that function, do 6, open parentheses, x minus 1, and then x plus 3. Starting at -3 there, I've got a y value of 0. At -2, I've got a y value of -18. -1, I've got a y value of -24. Let's double check. I put a 6 instead of a 2. Sorry about that, guys. So let's go back and change that function. I've got 2, open parentheses, x minus 1, close parentheses, open parentheses, x plus 3, and then close parentheses again. So let me go back and change some of these values. I was like, man, that's pretty big. So -3, 0, -2, -6, that's a lot more reasonable. -1, -8, and 0, -6. And we're back to 1, 0. So -3, 0, -2, -6, -1, -8, 0, -6, and 1, 0. Notice that our x-intercepts do occur at 1 and -3. And this is a symmetric parabola. Guys, that concludes the part where we're really going to talk about graphing from a table. In the next video, we're going to get into how can we tell what the function is and looking at some of the transformations.